This is 4.1 radian and degree measure, and this happens to be day 2. All right, so the next thing we're going to do is we're going to get started here, and we're going to, I'm going to work an example, and then I'm going to give you a couple of problems that you're going to work, and you're going to bring those to class tomorrow, and I'm going to check them off for a daily grade. All right, the first thing we're doing, and this is all coming from your 4.1 notes that I know you have all taken. If not, you need to go on YouTube or go to the playlist and look at the 4.1 introduction notes. Remember, this is all new and we need lots of practice. The first thing we're going to do is determine two coterminal angles. Let's review for just a minute. Remember that coterminal angles, if we're talking about our unit circle, coterminal angles, and I'm going to pretend like there's a circle there, start at the same location and they end at the same location. So if I rotate this angle to here, this is my initial side and this is my terminal side. And to be coterminal, I would have to start here and I could go the opposite direction and end there. Or I could start here and I could go in the same direction but around again and end there. So they can't be the same angle, but they have to all start in the same place and end in the same location. All right, so we know that each time we are making a rotation from the ending spot 360 degrees, or one revolution of the circle, which you know now to be 2 pi. We talked about that today. So we're going to be either adding or subtracting 2 pi, or adding or subtracting 360 degrees. All right, let's look next at determining coterminal angles. Here's your example, and then I will give you your two problems. The example I'm going to give you is theta, your central angle, is 2 pi over 3. All right, I need a coterminal angle, one positive and one negative. So I'm going to take 2 pi over 3, and I'm going to either add 2 pi to it, or I'm going to take 2 pi over 3, and I'm going to subtract 2 pi from it. Well, I can't do that without using those reference angles we talked about or converting my denominators. So 2 pi in thirds would be the same as 6 pi over 3, because that would be your reference angle. So remember, today I told you to write those down. You're going to use them a lot. So for thirds, you're really thinking of 6 pi over 3. When we add 2 pi and 6 pi, we get 8 pi over 3, and that would be our positive coterminal angle. Again, we're going to add 2 pi, but in thirds, that would be 6 pi over 3. And if we have 2 pi minus 6 pi, that would be negative 4 pi over 3, and that would be my negative coterminal angle. All right, here are your two problems. All right, these are your two problems. That's kind of didn't make a mess of that one. That's a negative 9 pi over 4, and this is a positive pi over 12. So for each of these radian measures, excuse me, I want you to find the coterminal angles, a positive and a negative one. Even when you have a negative, remember, you may have to choose a multiple of 2 pi to get your positive and negative, but maybe not. Check it out and see how you do. Remember, you're adding and subtracting 2 pi each time, or you may have to add 2 pi twice if this negative is really large to get to a positive. All right, so check it out and see how you do, and we'll check our answers tomorrow. I'll be looking for this work in class. Let's go on to our next example. This time we're going to do two coterminal angles, and I believe we will be giving this in degree measure. In degree measure. Here's our example. Again, this time it's one rotation, but we won't be using radians, or we won't be using 2 pi, we'll be using 360 degrees. So here's our first example of that. We have theta is equal to 240 degrees. And I want a coterminal angle, one positive, one negative, to 240 degrees. Same thing, starting and ending at the same location, still adding or subtracting values of 2 pi, or in this case, 360 degrees. So we would have 240 plus 360, and that would be actually 600 degrees. And we would have 240 minus 360, and if we subtracted, that would be negative 120 degrees. And those would be your two coterminal angles, a positive and a negative one. All right, here are your two to do. All right, there are your two examples. theta equals negative 180 degrees, and number 4 would be theta equals positive 230 degrees. All right, let's move on to our next example. You may want to pause and write that down, work those two, and then move on. Next, we're going to write each angle in radian measure. Each angle in radian measure. And this comes straight off of your unit circle. Straight off of your unit circle. So make sure that you have that in front of you for right now. But remember, tomorrow we'll have a quiz on recreating the unit circle, the degrees and the radians. So let's start with, all right, our example is 150 degrees and we want to write it in radian measure. Well, if you remember from our unit circle, 150 degrees, remember this is 180. And if we're rewriting it in we're rewriting it in radian measure, 180 is the same as 2 pi. And 150, be careful, remember we have 30, I'm just going to mark them, 45, 60, 90. And then you have back 30 would have been at 150. So we know that that's a 30-degree angle. So because that's a 30-degree angle, then you have to think about this being pi. 30 degrees, remember our 30-degree reference angles would be at 30 degrees or pi over 6. And we're going to go backwards here. The reference at pi would be 6 pi over 6. And if we move backwards, it would be at 5 pi over 6. Now, if you've already created your circle, then you would be able to look at it. And on a test, I would just draw out my circle, reproduce it, and then I would just use it on my test. So 150 degrees in radian measure is 5 pi over 6. All right, here's your 2. All right, there's your 2 examples. Number 5, convert 30 degrees to radian measure. That should be a pretty simple one for you. And convert 120 degrees to radian measure. All right, I'm going to move on. If you need to pause, please do so you can work those problems. Next, we're going to write the angle in degree measure. So we're given radians and we're going backwards. Again, straight off your unit circle. I'm just going to give you your 2. This is the same thing. Look at the unit circle, and now you're going back to degrees. So yours would be here are your 2 to rewrite. You have 3 pi over 2. I want you to give me the degrees, and 11 pi over 6. I want you to give me the equivalent degrees. All right, moving on. Degrees. Oh. I'm going to repeat this. I'm sorry. I can't remember if I'm recording or I might have paused myself. I don't want you to make sure I didn't miss this. This was converting the angle from decimal to degree form. We started with 54 degrees and 45 minutes. 45 minutes is simply a portion of a degree, a partial amount, a percent or a fractional part of a degree. And so we're going to convert that by doing 54 degrees plus 45 out of 60 minutes. It's that part of a degree, and there's 60 minutes in a there's 60 minutes, so we're going to convert it that way. So 45 out of 60 would be 3/4 or 0.75. So 54.75 degrees would be your answer. And that's in decimal degree form. All right, now you're going to have 2 examples to do and practice on your own and bring to class tomorrow. Okay, these are your 2 examples. I want you to convert to decimal degree form, 45 degrees in 10 minutes and negative 128 degrees in 30 minutes. And I will check our answers out tomorrow. All right, last little section. We're going to convert the angle back to degrees, minutes, and seconds. So degrees and then minutes, and then there's this little one called seconds. That's even a smaller fractional part of a degree. All right, let's start with an example, and you'll have 2, and then we'll be done for the evening. All right, when we're going the other direction, this is a full degree, 240 degrees, and then this is that part of the degree. 0.6 is a fractional part of a degree, and we're going to convert that to minutes. So we would do 240 this time, and then we would add to that, so that's the degree part, and then the 0.6, you're going to go 0.6 times 60 this time, and that's going to equal 36. So all of this becomes 36 minutes. So your answer is 240 degrees and 36 minutes. That's your answer. So to go from decimal, you multiply. To go to decimal, you divide. All right, here are your last 2 examples for the evening, problems 14 and 15. I hope I haven't miscounted. And remember, 4 in the middle, you're just writing down, and we're going to work in class. These are the last 2 for you to work and try to work on your own. If you want to set them up like this part of the work right here and then get to class on these that you might need a calculator for, feel free to do so. But by the time I get around to you tomorrow, you should have them ready to go and for me to check your answers. All right, so we're going to try negative 145 degrees, I'm sorry, 0.8 degrees. And then we're going to try 2.5 degrees. 2.5 degrees. All right, do those, and we'll keep going tomorrow in Unit Circle. Don't forget, we'll have a quiz of recreating the circle tomorrow. We'll check these answers and make sure that you've done this work for a daily grade and homework grade as well. And I guess that's it for the evening. Have a good evening. Good night, Bearcats.